I was going to try to give you a little bit of background, I guess, on how I came up with this title. I really couldn't think of a title for what I wanted to present, and what I wanted to present kind of goes all over the place. It's not, I think some topics have a natural flow to them, where this one kind of jumps around a little bit. And really the reason that I wanted to talk about this topic was, as with most things in my life, it was born out of frustration. And so in my role, a little bit about me, my role, I'm a pre-sales engineer, which means I am responsible for the design, scoping, kind of everything up till when delivery engineers go in and deliver projects. And my focus is these days really just on desktop virtualization. A number of years ago, I actually was a customer of the company I'm working for. I managed the server, DBAs, had an AS400 in there too, and I also had desktop architecture. And so I've had a long background with server virtualization technologies, going back to the VMware ESX 2.0 days. And now really my entire life is consumed with desktop virtualization, which is fun and it's hard. But what I wanted to spend my time here doing is kind of, I guess, letting you know a little bit of what I see in going out and talking to customers. Some of my frustrations really are around people who have already chosen their storage solutions, already chosen their server solutions, and I want to make sure that people understand that those decisions that people are making, that those ultimately are impacting your VDI design. So it's not so much about VMware View or Zen Desktop and how whether you should do Zen App versus desktops or do RDS versus a full Win 7 desktop, but really around the hardware components, which, I don't know, I find them sometimes a little bit dull, but I'll try to spice it up. A little bit of background on me, so I have a blog, and I post on that fairly regularly. Again, most of the things that are on there, most of the things that inspire me to write are things that annoy me, so some of my blog posts are rather spirited. And then also, I do spend a fair amount of time on Twitter, and with all my presentations, I'm always encouraging people to spend more time on Twitter, and a lot of people, I think, maybe have tried it in the past and maybe not found it very useful. So I want to maybe give you guys a quick kind of background on how Twitter has personally affected me, because I'm completely confident that I would not be up here today if it wasn't for being on Twitter and being active, I think, in the community. So a few years ago, I attended Microsoft Tech Ed for a number of years, and I would go to Microsoft Tech Ed, and I'd usually be there by myself, and I'd attend sessions, and I'd go to lunch, and maybe I'd be sitting at a table with somebody who also wanted to talk a little bit, and we'd share a few things over lunch, and then I'd go back to attending sessions and basically sat quiet for the course of an entire day. At night, I'd attend the little parties and maybe find one or two people to talk to, but for the most part, I was spending that time by myself. And what I realized this year at Citrix Synergy, which was in May, was that every night that I was there was really filled with basically hanging out with 20 other people that I had met through Twitter that all had similar interests, in some cases very similar jobs to me. Oh, you're fine. And then we were sharing information about how we do things, the issues that we have, and I'll even, I'll take Jarian here up in the front row. I've gone so far as to, when I have questions to, we don't work together. In fact, if we did work in the same area, we would actually compete. But I'll ask him on Twitter questions that I might have that I know he has the answer to that somebody locally I just don't have access to. So, the company I work for, they're big and hip on rolling out more internal IM, and I'm completely disinterested in instant messaging within a company or even within a region, because I've started using Twitter so much that really my IM is Twitter, and I regularly have conversations with people across the world that have similar interests. And so that's my plug for Twitter, and I think if you're following the right people, I definitely don't have people on my list who are, tweeting about their bathroom habits or what they're having for lunch. That doesn't interest me. And I try to use it more as a work tool, not as a personal tool. So most of what I have on Twitter is not personal in nature. Although I did take a picture of a lake I was near recently and put that on there. I was like, oh, should I put this on there? Oh, it's a really cool picture, so I did. I also am a VMware vExpert. Essentially, that was also, I think, through both Twitter and my blog that really got me that award, and it got me a blogger pass to VMworld next month, so I'm pretty excited about that. So, as you saw on the first slide, really what I want to talk about today are the decision points around making a hypervisor decision, and depending on the solution you're choosing, that decision might already be made for you, so we won't spend a ton of time on that part. And then decisions around servers, rack mount versus blade servers, local storage versus shared storage, and that's going to bleed over into the last part where we're going to talk a little about some of the storage options that are available and how those storage choices can be impacted by your hypervisor decision or how they might impact your hypervisor decision, and also in some cases your server decisions that you're going to make. So first of all, if you are doing hardware design prior to knowing what it is that you're going to deploy, turn back, right? You've got things in reverse. I've been working with a rather large customer in Denver for the last 18 months. They actually spec'd out all of their hardware prior to really understanding their VDI design. And for the last 18 months, we've been trying to undo that. Essentially, they bought a bunch of blade chassis, a whole bunch of storage, which is having difficulty scaling to the numbers that they're trying to achieve. And what we realized a number of months ago was that if they had maybe chosen a rack mount server solution with local disk, since they're doing non-persistent desktops, not only would it cost about 1/10 of the cost that they have invested today, but it would have much smaller failure domains. It would be much more scalable for what the numbers they're trying to reach. And so my warning to you is just, don't do hardware design first. I'm not going to spend a lot of time on this. I think a lot of people here at BriForum have a lot of warnings for people about this, but being that I'm the person who gets to go out and talk to customers when they say, do you have an interest in VDI? They say yes. So I show up and I ask, well, okay, so my first question, what business problem are we solving? And 50% of the time, at least, there is no business problem, or they're completely unaware of it, or it's because their boss told them to. So again, please make sure you have a business problem we're trying to solve before embarking down the path of VDI. And then obviously, going through that process, you'll be determining user groups, applications. And I think the most important part here is that really in order for us to do pilots, people always want, well, how many users can I put on this? Every environment that I've gone into is different. And believe me, if I could make it more cookie cutter, I would do that. It would make my day easier. But the most important part really is that if you're doing a pilot and you're gathering data out of it, it's going to help us when we start talking about what hardware do you need to have in place. How big are those clusters going to be? How many clusters might you have? So the data is really the most important part. And really how that's going to impact our design is at the end of the day, what we're trying to figure out in a VDI design and a hosted virtual desktop design is how many VMs can I put on a host? Depending on the number of desktops you're trying to deliver, that's going to impact how many hosts we actually need to have. There are design constraints, so that's going to then impact how many clusters we need to have, right? In a lot of these architectures, we're not going beyond 8 nodes in a cluster, and so if we need 13 hosts, we know we're into two different clusters. And then there are a lot of management infrastructure constraints too. So as we start tweaking some of these numbers, when we look at failures that are going to happen, we have to keep in mind that there are management infrastructure limits. There are bottlenecks that will exist within management infrastructure. For example, vCenter would be an example of that. If we're going to maybe try to simultaneously power on 250 virtual machines, we know that's going to take a while, and so therefore we might have smaller hosts. And then also, if we have storage I/O or capacity limits there that we need to build around, whether it's because we want to minimize the size of the failure domain, or because there's just a limit as to how many IOPS you can push through your storage array, that's also going to impact then, kind of what our overall design looks like. So I know there are more hypervisor options that are out there than this, but this is all I'm going to cover today, and this is all I really see to some extent in the market today. I have a long vSphere background. Citrix Zen Server, we actually spend a fair amount of time on that as well these days, and I'm looking forward to the next release of Microsoft Hyper-V. As I said earlier, if you are a VMware View environment, your choice is already made for you, but we're going to go through, for those of you who may not have a VMware View environment or looking at Citrix Zen Desktop, what some of the other options are, and then ultimately I think, where we are today, what my advice to you would be on that. And so just a little bit of what I see in my market is about 85 to 90% of the time, we're doing a vSphere environment. Now that might be because I'm encouraging them to do a vSphere environment, but that's what our customers are running. And then the rest of the time, it's really a Citrix Zen Server. Most of the time when it's Zen Server, it's because the customer has some cost constraints, or they are looking at having a 2 hypervisor environment for other strategic reasons in their environment. And I think I've got maybe one customer, maybe, so I put that like a tilde there, about maybe 0%, but I don't see Hyper-V 2008 R2 as a hypervisor in really any of my customers today. However, I do expect, if I were to do this presentation again next year, I would expect basically Zen Server and Hyper-V to probably almost completely swap there in numbers. I fully expect that I will be doing, or our delivery team will be doing more Hyper-V deployments next year. Did you?
Unless I missed it at the beginning, what are the average size of your customers?
So we're kind of all over the place. So bothers me sometimes, but we've got customers all the way down to like 100 users and as large as about 40,000. So I would say I spend the majority of my time probably in accounts that are north of 500 users. So I don't spend a lot of time in accounts that are smaller. Not that they don't want desktop virtualization solutions, but they just have limited value that ultimately something like that's going to provide. And a lot of times they have limits on the infrastructure that they can invest in. So does that answer your question? Okay. So in the Zen Server world, for those of you who are considering Zen Server as an option, and as I said, I do expect that Hyper-V will come on stronger next year. In the storage stack, if you're going to be doing it, my advice to you would be to use NFS. If you are a Windows administrator, how many of you in here use Zen Server? Maybe that's a good question first. How many are? So for those of you who are using Zen Server, I'm probably not telling you anything you don't already know as it relates to LVM. And that for a Windows administrator, that's sometimes a little bit of brain damage to understand how logical volume manager for iSCSI or Fibre Channel works. Other options would include StorageLink, which is basically an application that used to live off host and now is actually on the hypervisor host itself, and it's responsible for going out and provisioning storage. So if you were to create a virtual machine, it would create a one on the storage, provision it in through the hypervisor, present it to the virtual machine. So it's a one-to-one mapping of disk to LUN on the back end. However, my reason for the sigh here is that the deployment methodology for StorageLink keeps changing from on the host to off the host, and the list of storage platforms it supports is pretty darn short. So most of our customers that are using Zen Server are on typically LVM over iSCSI or LVM over FC. Unfortunately, we don't have a lot of customers that are using NFS, but I do think it is the best option if you're going down that path. One of my biggest, issues that I've had for quite a while with Zen servers, there's just a lack of third-party integrators that are out there that are integrating into the Zen Server hypervisor, specifically around some of the backup recovery solutions that are on the market, security solutions, things like that maybe, like for example, do antivirus that work with, specifically the Zen Server hypervisor. And this one is actually why we do it. There's a lack of skilled engineers in the market. So when people need help, we're some of the only people in town that have Zen Server talent. But if you're a customer and you're implementing this into your environment, you should probably be aware that there are less people that do Zen Server than do vSphere. I often joke that you can probably go into any supermarket and find 2 VCPs in the produce section. It's maybe bad if you're looking for a job. It's good if you're an employer and you're looking for talent in that area to do vSphere. So it is a lot more difficult to find skilled resources there. And then another thing that kind of differentiates Zen Server that changes our design or what we have to think about in that design is that the management infrastructure. So in vSphere world, we have vCenter to manage clusters. In the Zen Server world, we don't have a standalone management host providing that. It's built into the hypervisor. So it does change a little bit when we're thinking about, what do I have to plan for in my VDI design? Do I have a single point of failure with the management infrastructure? Do I need to, how does that scale with my solution? How do I provide HA for that? Microsoft Hyper-V. So like I said, to me, 2008 R2 isn't relevant at all. With the new release coming out, I would highly doubt that anybody's going to go and roll out an older version of Hyper-V. But I am extremely excited to spend more time with the next version of Hyper-V from Microsoft. And for me, the big changes were, and I don't know if everybody was aware, but there were some things that happened within the 2008 R2 world which would cause basically redirected I/O to flow through a single host. So you could end up locking a LUN, and when that LUN was locked, say by things like VSS, all of the I/O to that LUN would then be redirected through the host that was locking the LUN. So in larger environments, that was a pretty big potential constraint where we're pushing a lot of I/O through one host, and it could also add some latency to the disk. But in the next version of Hyper-V, we've got things like the offloaded data transfer. So if you're familiar with VMware vSphere, where we're talking about VAAI, this would be similar to that, where we're actually offloading storage tasks to the hypervisor as opposed to offloading those tasks to the storage versus doing them in the hypervisor. Like I said, there's the redirected mode that is actually being removed for most operations. And then we have a lot more storage options. I'll be curious to see how many people are rolling out SMB storage and using that as a storage platform, but I think for some of our smaller customers, that might be of interest to them. A big one that I haven't seen a ton of talk about yet with VDI, but is a big impact when we're talking about VDI design, is going to be CSV cache. And so CSV cache is basically, if you're familiar with CBRC in the vSphere world, content-based read cache, CSV cache works in a similar way where it's actually caching blocks of data in memory that are being read off of disk. So it can, in the case of a link clone, we're caching those frequently read blocks in memory, and this is a read-only technology. It's not doing write caching, which is the bigger challenge in VDI, but it is giving us some read caching. And the reason I put that in there is that while it's not a huge amount of memory, actually in Hyper-V you can, I think, turn it up to as much as like 40% of the host memory or 40 gig. I don't remember which one it was, but it is not a fixed amount. You can actually increase it quite a lot. This could potentially also then be something you need to be keeping in mind as you're figuring out how much memory you need to put into your servers, because you might be wanting to use this cache as opposed to letting those read IOs go to disk. And then, in typical Microsoft fashion, they have lots and lots of partners that extend their solution. Solutions that are going to be in the network stack. I did not talk about it with Citrix Zen Server, but they're using Open vSwitch. There are some third-party integrations there. There are already, I think, more third-party integrations on the networking stack from Microsoft on a product that's not even out than exist within Open vSwitch and Zen Server. So a lot of rich integration that I would expect to see in the future, beyond what I see in the Zen Server world. And then the big one for me that I think when I'm talking about hypervisor design or where the challenges typically lie, it's usually around storage and networking. And those were the two pain points really that I had with the previous version of Hyper-V. So network teaming support being built into Windows. And as I mentioned before, some of the things they're doing with storage, which should make design when we're doing it on top of Hyper-V much easier than what it would be if you were doing it today. And so my recommendation to customers, as I said before, is really today your best option when designing for VDI is to use vSphere. Now the downside to it is it costs probably the most of any of the solutions that are out there, depending on what you're buying. I mean, if you're buying VMware View, you're getting vSphere with that license, and it is your only option from a hypervisor perspective. But for me, it's still the most feature rich. It's got the majority of the support because it has the majority of the market, and it has the largest base of engineers. So if you're a manager and you're looking for talent, this is the hypervisor where you can go to the supermarket and find your next recruit. But the downside being the highest cost, something to take in mind. So like I said, we're going to jump around a little bit. So for the rest of the presentation, I'm going to really just focus on vSphere as a hypervisor, not so much Zen Server or Hyper-V, because that's what I see in the market today. And so for customers that are running vSphere, how many of you have vCenter virtualized? And how many of you, maybe the better question is, how many of you don't have vCenter virtualized? Okay. So pretty common then to virtualize vCenter. The one thing I do see that is often left out of the design of VDI is high availability for vCenter, or even what happens when the cluster that vCenter is on maybe has some faults, right? Where are you going to locate it in your environment? And so in very large environments, a common deployment method I see for vCenter, and even for the management infrastructure, are completely separate clusters. So where you might have a management cluster that just hosts vCenter instances. In the account we're working on that is planning on going north of 10,000 users, it's a pod design. We do have multiple vCenters. They are actually deploying a management cluster for just vCenter in their environment and in their regional data centers. For those of you maybe that don't have enough resources to have a standalone dedicated cluster for vCenter, another option would be to, at least if you're going to have it, maybe in shared across an 8-node cluster. If something were to happen, the biggest thing really is, can you quickly locate it and turn it on? Because that, if something were to happen that would take down your entire cluster, the first thing you're probably going to turn on, besides maybe like domain controllers, if those are indeed still virtualized in your environment, would be the vCenter server. So what I often tell our customers is to do basically some VM to host affinity mapping. So you could do this through the DRS rules, where we can create a group of hosts that we would want to pin essentially vCenter to. So we know that if there is a failure, and if you've got an 8-node cluster, we know if all the hosts are off and I power them back on, I'm only going to have to look on 2 of the hosts at most to find vCenter, to then power it on, to then manage the cluster. So that's something I would encourage you, if you are running it in a cluster or running it virtualized, where you have a large number of nodes. It might save you some time in bringing it back on. So servers determine a lot. As I mentioned before, the customer who did a blade solution, it essentially dictated our storage solution as well, where they could have possibly looked at other options that might have been more scalable and definitely less expensive for them. It's also going to affect density. So when we're talking about 2 and 4 socket servers, how many VMs can we put on a host? Therefore, how many hosts do I need to have? Therefore, how many clusters do I need to have? Et cetera, et cetera. And it's also going to impact our high availability design. And I'll explain what I mean here in just a little bit. First of all, some fallacies. They're not all fallacies, but I think that they're on the wishful side of thinking that I hear a lot of vendors propagating out there. And I know that, the bad part of going on Thursday is you guys have been here for 3 days. It's been desktop virtualization session after desktop virtualization session. A lot of people have picked up on or have talked about some parts of my presentation already. So you might have already heard this in some previous sessions. I think Ron Oglesby likes to beat up on vendors about this as well. But I think that in general, I think vendors are if they're telling you can get away with one virtual CPU in your virtual machines for an employee that gets paid $50,000 or more is completely false. I have most customers that I know that have, I wouldn't call them power users, but definitely not call center workers. They're not the receptionist. They need more than one virtual CPU in their VM for it to be responsive. And the reason for that is, applications are multi-threaded. Intel a number of years ago told everybody that if you want to take advantage of the horsepower that we're going to be building into our Intel servers, then you should multi-thread your applications, because our processors are not going to be faster, we're just going to have more cores. And so software manufacturers multi-threaded their applications. And then I see people go and drop these, one virtual CPU VMs into their desktop environment and try to run said application and then it performs, negatively. On top of that, the other thing that I want to make sure you understand is that when we're, say, a user's working in Excel, not only is the processor being basically, context switched for Excel, but also all the encoding of, what's going on in the screen is happening in CPU as well. So, you're kind of, in order to deliver, say, rich content like a video off of YouTube server-side rendered, there is no hope of doing that well with one virtual CPU, just because you're going to have to render video, then encode it and put it on the wire. And those two things, it's just, if it's a microsecond, you're probably not going to notice that. But as you start fully loading these servers, there's more of a delay between all of these things happening. So one virtual CPU VMs, I do not think are real. I don't think that's going to be something that as we continue to put more cores into servers, that we're going to see people doing for a whole lot longer. It depends on the work, on the use case and the worker, but I think in general, 2 virtual CPU VMs is where I usually tell people to start. And that's going to impact, our sizing when it comes to our servers. The other thing that's out there that it might be accurate, it hasn't been in my experience, is the virtual CPU or VM to server counts that I see out there. And so, a lot of manufacturers will, I think Ron's quote is actually on Cisco, by this B230 blade, we can do 175 virtual machines on it. Okay, well, what if they're 2 virtual CPU, virtual machines? Saying it as a, count of virtual machines is kind of inaccurate. They're also using, reduced memory counts and things like that. But I think that in general, the amount of overcommit that you can do on a server is less than what I see quoted. What I see happening in real life are much lower overcommit ratios than what vendors are telling you can get. And as we continue to increase virtual CPU counts, that number is not going to go up.
Which number would you recommend? What is typical? What is a good ratio?
I don't tell people to go, if I don't know anything about the environment, and this is really, I think, where the pilot comes into play. But you see numbers out there where people are saying they're going to get 10 to 1. I usually tell people, let's start at 5 to 1 and then figure out where you are. It really, a lot of it depends on, what they can tell me about the applications that they're going to use and what their experience is today. And to some extent also you can get a little bit of information just by looking at the PCs that they're using, right? Well, why, I noticed that, on the way in that everybody's got a new PC. Why is that, right? Oh, it's because, the other PCs, our applications were slow in. What apps are you running, right? And so that's going to, kind of give me an idea about how much CPU horsepower they're really going to need. And I'm going to gear that virtual CPU to physical core count lower. But ultimately, this is the data that people need to be collecting for me, that need to be collecting out of a pilot, or using sizing tools. Sizing tools are a good way to go and predict it ahead of time. But, I work with salespeople. They don't like to slow processes down, go and get information. So.
Hey Dan, are those assessment sizing tools pretty accurate in your experience?
They're more accurate than guessing.
Yeah, right. But have you taken a report from one and went and built the infrastructure and it works?
Yes, yeah. The big thing is finding out. Usually, we're finding more out about the applications than they actually know.
Right.
So every environment's a little bit different, and some you get the sense that they don't even know what applications are installed, And typically we'll find that, hey, did you know that this application is using far more memory than you ever thought it would, right? Even things like web browsers that take far more memory than what people think, right? In IT, we're not the only ones that open up 50 tabs, right? There's a lot of people that do that. Also then, so on that note, the memory requirements, I think that in general, memory requirements that vendors are putting out there are, in general, I find them to be typically a bit low. I see a lot of people sizing this out with 1.5 gigs of memory versus starting out at 2 or 3 gig of memory in the virtual machines. And not having enough memory in the virtual machines just means that we're going to create some more disk I/O. This one I think has been definitely probably beaten to death for the last few years at BriForum, which is storage I/O requirements. Every environment, again, is different. Storage I/O, number one reason why I see desktop virtualization projects fail. And then, obviously, don't believe vendor estimates, get your own. Don't believe me. Get your own estimates, do your own pilots, and figure out, what your actual number of virtual CPUs is required to deliver a good user experience, or how much memory is actually required. So I was trying to think of a way to explain this, rack mount versus blades. Because as a customer, I remember when HP came out with their first blade chassis, we didn't buy that one. Then their second generation, the C7000, came out, and we got a couple of those. And looking back, I think I bought the blade chassis more because it was new and cool than that it was really solving anything for me. And I think that's still going on. I think maybe the perception is that a blade chassis is the supermodel, right? The supermodel who spends 2 hours a day in front of the mirror, who doesn't want to wash the car. I don't know, I'm just being a little sexist here, but versus the girl next door being the rack mount server. Because at the end of the day, a rack mount server can really do almost everything that a blade server can do. I think the only 2 areas where I see blades have an advantage, there's some I/O consolidation. In some cases, there's less power, but the power differences between blades and rack mounts is not as great as it used to be, and density, right? But I'm looking at my own decisions that I made, and I'm looking at the customers that I'm talking to, and I think for a lot of people, blades are the supermodel, and I think I like the girl next door instead. And I'll explain a little bit why I like that. And definitely going into these desktop virtualization projects, I see a lot of people who buy blades and then try to implement a VDI project. And what I want to make sure you guys understand is, that dictates a lot of design constraints into our environment. The big one for me is that blade chassis fail, right? So if you're planning on deploying VDI and you're, say, in healthcare and you want to never be down, then my recommendation to you is you better have more than one. You better be planning for blade chassis failure. Or you better put that onto rack mount servers. I have in here, I was actually a customer when I had a backplane fail, and that was about 4 or 5 hours of a guy in our data center with a whole bunch of parts strewn across the floor and a whole bunch of parts in his bag, tearing this thing apart, putting it back together, during which time the whole blade chassis was down. And then other ones I've seen, not so much hardware failures, but software bugs. So the things that are supposed to have all this promise of aggregating I/O, have an issue, basically disconnect all I/O from the blade chassis, taking the entire blade chassis down. And so if you are doing blade chassis, I would encourage you, if you are, some customers don't have requirements of 24/7, nobody's on the operating table and going to die. Okay, I can buy a blade chassis. But if you are looking for the highest availability, you need to, if you are building, buying blades, you need to be designing for N+1 at the chassis level, let alone at all of the other levels that we're going to talk about.
Is that an HP?
Which one?
The one that went down?
The backplane failure? It was.
IBM has a redundant backplane.
I know they say that. I don't see a lot of IBM for whatever reason in the market I'm in. Like I know there's a lot of IBM customers, and there's a lot of customers that use other things. I've seen failures on other blade chassis too. I just don't have enough, I don't know enough people that use IBM personally, although I know they're out there. So the other big one really for me in rack mount versus blade chassis are, what my options are around local disk. And so if you are looking at local disk solution, I think, Jaren, I know you're a big fan of local disk. If you are trying to design and build and deliver a non-persistent desktop, then local disk is a very scalable with a very small failure domain, because the disk is locally attached to the server. You lose one host, you lose the disk. You have storage contention, it's on one host, it doesn't affect other hosts, things like that. Then local disk is a great way to go. However, if you are using a blade chassis, then we've got either really expensive disks we can put in there, or we can look at other options. Up until, was it a few weeks ago? I think Fusion IO just recently announced support for mezzanine cards on the Cisco UCS. But our options as it relates to using things like that within a blade solution are limited today in the blade chassis world. So if you're looking to do a local disk solution, obviously I'm trying to encourage you that it's probably going to be easier to do that with rack mount servers, not with blade servers. So bouncing around a little bit here to talk about CPUs. This is hopefully the most text I'm ever going to put on a slide. I'll give you the short version of it. What I think, I think I incorporate this into almost every presentation I do now, which is, I think there's this, nobody really sits down and thinks about it, but there's no priority within a hypervisor. There's no priority coming from threads within the operating system down to a hypervisor to say, hey, this thread's more important than this thread. That's up to the operating system. And so the hypervisor really is just responsible for doing fair share scheduling based on your resource limits or reservations or pools that you have in place. It's just responsible for scheduling that work. It has no idea about priority within virtual machines. So if you've got something that's the highest priority in a VM and the operating system is aware of it, it puts it in its queue. But when it comes down to the hypervisor has no way of knowing that that's a really important task for it to work on. And so what happens at the end of the day is that essentially all resources being the same, or all reservations being the same, the more a virtual machine consumes, the more likely another virtual machine will preempt it. That's how it works. I mean, it's basically trying to share the processor out equally across all of the virtual machines that are requesting access to it. And so I think sometimes maybe this diagram helps a little bit as well. This is what you're doing with your physical PCs today. There's no hypervisor in between, and so when threads get scheduled, they go down to the the physical core. Excuse me. The physical core, and the core executes the work. If we were talking about remote desktop session hosts or a XenApp environment, we're typically doing a one-to-one mapping of basically virtual CPU that we're allocating within the virtual machine on top of it. Typically, there would be a hypervisor here. So what we're not doing is overcommitting basically virtual CPU to physical core. There's a one-to-one mapping of that. And hopefully you've maybe left one open there for the hypervisor itself to get some work done. But we're not overcommitting. So in theory, when work is pushed down from the operating system, there's always a physical core available for the work to be done on. And this is what people want to do in VDI, right? I've actually had people that said, my apps are slow in this, so I'm going to implement this, and then they'll be faster. How do you figure, right? Now, what won't happen is one user's workload is not going to take all of the CPU resources and another user's workload take none. You're all just not going to get anything, right? He could have probably gone back to this, put some tools in place to maybe cap CPU utilization, and it would have worked just as well. It would have worked with the same hardware resources better than this, right? So at this point, this is what people are trying to do with VDI. And if you look at their server environment, it's probably a lot closer to that than it is to this. So I'm always baffled a little bit by why people expect that the performance is going to be so awesome in this environment, or why they're not more concerned about virtual CPU to physical cores. And then on top of it, when I ask them how they're monitoring their environment, this is what they tell me. Well, I looked at my utilization numbers, and I'm at this is our lab, so we weren't doing a whole lot in it that day. But they'll maybe be at 35%. They tell me, well, I'm only at 35% utilization on my CPU. Everything's good, right? No. This is proper CPU monitoring. I mean, yes, if your utilization number is at 80% on this previous screen, yeah, we're out of CPU resources. But more often than not, what I find is that people have over-allocated number of virtual CPUs to physical cores, and they're not looking at percent ready values. I think this has been hit in a few different sessions, but I want to make sure that everybody that is running vSphere in their environment looks at these numbers. Because this ultimately tells you when you're out of headroom. When that percent ready value for your virtual machine is above 10%, you're done. It's either subtract virtual machines, subtract virtual CPUs, or add cores, or add hosts. That's all there is left. Anything else is not going to perform well on top of it. And then where I was talking about adding second virtual CPU to all of those virtual machines, the second value, I've got the two that I think are important here in bold, percent ready and percent co-stop. And percent co-stop is the amount of time the hypervisor is spending trying to co-schedule virtual CPUs. So, what you'll find in server environments is I see people that will, no joke, I had somebody call me up and they told me that performance was getting worse in their vSphere environment. This is a server environment. And they kept adding virtual CPUs to their VMs, and the performance kept getting worse. I was like, well, stop doing that, right? If it keeps getting worse every time you add a virtual CPU, logic would tell you, maybe, hey, what you're doing is not helping things. But what they had no idea about was, the fact that really what they had is contention of the virtual or the physical cores. And this is just in a server environment, let alone desktop virtualization. And all they were doing is really driving up the co-stop values in their environment. All they were doing is increasing the amount of time the hypervisor had to spend trying to co-schedule work across those 4 virtual CPUs. So this is okay, right? If it's at 80, that's bad. This is better. And ultimately, when your percent ready goes high, you're done. That's how you know when your server is full. And typically, if you're going to do a pilot, that's what I would be encouraging people to take a look at to determine how many virtual machines they can really put on a host. And when you're doing 5 virtual machines is like when we were talking about RDSH or XenApp, where every VM has a physical core. There's no contention for the physical cores in the box. So you really, in order to do that performance testing, you really have to load it up with the number that you think is actually going to, or the target you're trying to hit on a host for production, not 5. If your goal and your price model works at 70, then you better have 70 users on that host in order to test it properly. So 2-socket versus 4-socket. Since CPU is so important in the environment, well then, I should probably have more sockets, therefore more cores. Okay, maybe. So smaller hosts, smaller failure domain. Depending on how you're doing your virtual machines. For instance, if you have persistent virtual machines and shared storage, you need to be aware that, hey, when that host fails, and I might be taking down then a larger number of virtual machines. I'm going to be putting a higher load on my management infrastructure to do those power on operations. It's going to take longer when a host fails for me to be back up and working versus a smaller server where you would have less VMs and therefore less VMs have to be powered on, and those VMs are going to be up faster. But on the other hand, smaller hosts also mean that you might hit your cluster size limits sooner. Right, so if you're using link clones, for example, in say a VMware View environment or MCS in a Citrix Xen desktop environment, link clone limit of 8 nodes. So your cluster sizes are not going to be larger than 8. And so when you start figuring out these numbers and you're like, okay, if I can put 75, I got 1,000 users, and I can put 75 users on a host, on a 2-socket host, that means I'm going to have 2 clusters, right? Well, maybe I do 4, or I do 4-socket cluster, or 4-socket nodes. That gets me, much closer to my 1,000 number within a single cluster. Of course, now if you have n+1 hosts, you're probably back to looking at 2 clusters anyway. But just it's something to keep in mind, because it's going to, as you start in the larger environments where you start talking about multiple clusters and multiple n+1 nodes in clusters, it's going to change the overall design of your VDI environment. It's going to change your costs as well. I was pulling this from all of the latest and greatest servers that were out there. I was actually surprised that somebody was able to put 26 drives into a 2U server, but those are out there. More commonly, you'll see 16 drives in a rack mount server. So going back to 2-socket versus 4-socket. In a 2-socket scenario, it's pretty likely that we can put enough local spinning drives into a server, as I was showing here, 16 drives, 175 IOPS, 2,800 IOPS. It's not rate adjusted, but if you have 75 users on a host, you're probably pretty close with just that number right there to being able to have enough local disk in a 2-socket system to support a reasonable number of users on a 2-socket server. However, if we go up to a 4-socket system, we're now probably a lot farther away, if we're using spinning disk, from being able to support those users with local spinning drives. So then you might be possibly looking at eSSD, the enterprise SSD drives, or like eMLC or SLC drives to support users if you're going to go the 4-socket route, or PCIe NAND flash cards. But only thing I wanted to, I guess the big takeaway here is 2-socket system, you can probably do the disk spinning local internal and support the number of users on the host. 4-socket server, you're going to have to look elsewhere. And so this was actually interesting for me to do. Anybody who's been IT knows that a 4-socket system is not twice the cost of a 2-socket system, which is why we never really considered 4-socket systems except for things that had to scale up versus scale out. And so I used one of our internal resources and had them go off and quote this with a few different vendors. And these are some boxes that just came out. And I got some interesting information. So I went out to Dell.com, priced it out myself just to make sure that our inside person did not screw up some quantity or put something in there that I didn't want. And this is what I found. I don't know if any of you have priced these out in the last few weeks. So the change here really is that on the 4-socket systems, and this is, like I said, pricing off of Dell.com. If you click large enterprise or whatever and just price it online, this is what I got.
Yeah, you should be able to get 30 to 40% off that, right?
I don't make those rules.
Yeah, I know.
I'm a pre-sales engineer, not sales. But the E5 4600 really is in the 4-socket systems. Those are the processors that just came out. You can do that with 8-core. You can put 768 gig of memory. And the cost premium was somewhere between 3 and 18%, which was a little bit shocking to me because I've really never considered 4-socket systems as a way to grow a VDI environment. So, and were you guys all expecting like 3 times the cost for a 4-socket system? Yes? Or did you think they were twice the cost? Did you guys already quote these out already? Okay. So on CPU for servers, as I said, more is better. We can do 8 cores in E5, 10 cores, E10s. Do the price, do the math, and figure out where you're scaling linearly price and processor and memory counts. But one thing I don't see out there a lot, and I don't have an answer for this, is in the server virtualization world, when we're looking at like VMmark results, the results are pretty favorable towards Intel in general server virtualization environments. What there's an amazing lack of, and I'm kind of curious if anybody has done their own benchmarks, is that on the AMD side, there are processors out there that have 16 cores in a single processor, and they can do 2 to 4 of those on a box. I don't see any benchmarks out there to compare AMD to Intel. But as we continue to push to put more virtual CPUs within the VM and more VMs on top of the box, I would my money would be that AMD would probably outperform an Intel. Yeah, I haven't priced it out either. So on the memory side, buy a lot of it, don't run out. Memory is cheap compared to, say, disk resources. So what we don't want to have happen is balloon drivers inflate. We don't want memory contention on the actual hypervisor itself, where it's going to be pushing things to disk or swapping locally. 16 gig DIMMs are pretty common, so we're designing these days around 16 gig DIMMs, really not any smaller than 192 today, and we're starting to see more designs of like 384. And if we're going to go, I don't have any 4-socket systems like I just showed you there that have 768, but maybe that'll be in a year from now or so. So hidden memory requirements that I think people forget about, that if you've got twice as much memory as you actually need in the box, this probably doesn't matter at all. But if you're just taking the number of virtual machines you have and say, oh, I'm going to put 75 VMs on there, they're all going to have 2 gig, 150, 192, I'm good, right? Well, that's getting a little close. And so here's some areas that I think people forget about when they're looking at memory requirements. So I should put a screenshot in here, but if you look at your vCenter, if you look at one of the virtual machines, under the resources, you'll see a little line there for memory overhead. And memory overhead is memory that the hypervisor is using, and it's based on the number of virtual CPUs you have. So like I said, if we're increasing the number of virtual CPUs in our virtual desktops, this number is going up too. It's impacted by the amount of RAM we have on our virtual desktops, which I would contend people need to start putting more in. The amount of video RAM that's assigned to the virtual machine. So if you're doing things like, say, in like a VMware View environment where you're assigning 2 or 3 screens and higher resolutions, that video RAM that number is going to be higher, as well as the memory overhead is going to be higher. And then things like 3D support, those things all drive memory overhead on a per VM basis up. And so in just kind of spot checking a few different environments and looking to see what we're using on average, I mean, on average I see about anywhere from 57 to 65 megabytes of memory for every single virtual machine in there. So if you're talking about 100, that's a few gig of memory that you need to start accounting for. And then the other thing is memory pressure. And so making sure that you're taking the amount of memory that you are assigning to a server, like if it's 192, and figuring out, subtracting out the percentage of when basically the hypervisor is going to start trying to reclaim memory. And so the default is 6%. And so like my example here is for 384, but if it was half that, it'd be 12 gig. So it's just, when you're doing your memory sizing for a host, we just need to do a little bit more than multiply VM times amount of memory that's assigned to it. Also, and I've got some links, and so I'm going to post this on my blog, and it'll be posted for all of you that are attending BriForum, so you don't have to write down the URLs, but I just wanted to put in here where some of this information can be found. In other hypervisor platforms, you also have to be planning, obviously, for the hypervisor and its memory needs. And then the other one that I hit on right away was, as we start seeing more hypervisors support storage read cache at the hypervisor level, that's another thing that's going to be needs to be taken into account when you're doing your memory sizing for your hosts. So VMs per data store. So this is go back a couple of years ago, and this was brain damage because the number of VMs we would put on a data store was not that many, and so we had a lot of data stores. We had a lot of LUNs, and in environments where they had different storage backend, you might have we were even hitting connection limits with some of the storage arrays that were out there at the time. But since 4.1 introduced some support for basically offloading that to storage, namely ATS, or Atomic Test and Set. The amount of virtual machines that we can put on a data store has gone up drastically. If you are planning on doing a VDI deployment, I would encourage you to be on vSphere 5. The reason for that is the numbers up here. So in 4.1, they basically supported it for two different primitives. So there were still things that would basically occur within a VDI environment, the other 6 primitives, if you were using any of those, that would still not use ATS to basically make metadata updates to the LUN. And so you could still, there were still a lot of times when essentially you would go back to using SCSI reservations in order to make updates to shared LUNs. So in vSphere 5.0 Update 1, all 8 are now supported. And so the guidance from VMware on data stores, VMs per data store is 140, so be less than that. If you want to follow what, VMware sizing is, it's, I think, typically, smaller than the maximum, closer to like about 125. And I know that Nick, and I can never pronounce his last name, Rintalan, that he posted something on the Citrix blogs to kind of update people as to how many VMs he would recommend per data store. And so he was using a number of roughly half that. So he was in the like 50 to 75 range of VMs per data store. So that's and our deployments today, the ones that are on 5.0 that we've done in the last few months, they are closer to about the 50 number, just as some, I guess, what we're doing. So this shouldn't be a surprise. You've seen that if we want to do local disk, that's going to impact our server design. Local disk gives us a much smaller failure domain. And I hope you understand what I'm saying here, which is just that if you have a server and you are using local disk in it, the failure domain is so much smaller than, say, like take a NetApp array with 2 controllers, right? If that thing crashes, you're going to take down everything behind it. That's obviously going to be much larger than using a local disk solution where if it fails, you're just taking down the few VMs that were on that single node.
Dan, have you used the virtual storage appliance option in vSphere?
No.
Okay. That's out, right?
Yeah, nor do I know anybody who has.
Yeah.
Anybody here use the virtual storage appliance within vSphere to do VDI? Yeah, I wouldn't think so.
vCenter has one too.
What's that?
vCenter has one too.
Yeah. My impression of the virtual storage appliance and talking to others is that it's really intended more for the SMB, and there's no, as it relates to, say, something like View on top of that or Zen Desktop on top of that, that seems pretty sketchy. But local disk really is only an option for people that are looking for non-persistent virtual machines. If you're doing persistent or you're using personal vDisk, or we'll see what happens with Lenovo when that's also integrated with View, using local disk is out the window, right? You're looking at some sort of shared storage option. Common question, what should I use, iSCSI versus Fibre Channel versus NFS? VMware has done test after test to show the performance of any of these protocols or even RDMs is essentially the same. And their support for the protocols is today essentially the same across all of the protocols. So for me, unless you are, say, making a decision around, say you want to implement Zen server in your environment, going back a few slides, my recommendation then would be NFS. But in general, use the one that I guess works in your environment the best from the storage manufacturer you like the best. So a few of some of the hidden capacity requirements that people leave out, and I know this has been talked about in some previous sessions, but it's overlooked in almost every sizing that I see done. One is the vSWAT file. So that's essentially it's a file created with your virtual machines, typically in the same directory as the virtual machine itself, and it is equal to the amount of memory assigned minus the reservation. So if you go and reserve all the memory, or half of it, then your vSWAT file is smaller. Right? You might have some other design constraints around how you're going to handle failover of virtual machines, or maybe you would not end up doing failover of those virtual machines if that host were to fail because of the reservations that are included in there. But for example, if you have a 4 gig of memory on your virtual machine, you're going to have a 4 gig vSwap file by default. Multiply that out times 75, and those storage requirements go up very, very quickly. Much smaller one, I wouldn't worry about it, but there is, just so you're aware, that memory overhead we were talking about, there's actually a vSwap file for that as well. So if you're doing any of the new virtual hardware, you'll see that created in that directory as well. So if you look in there and you're like, no, Dan was wrong, it's really, really tiny, you're looking at the wrong one. Page file. So the Windows page file, I know that, I think Ron's answer to this, when somebody asked in a previous session, should I get rid of the page file? His answer was flatly no, and that would be my guidance as well. But you do need to plan for the page file as part of your storage capacity. In a Zen desktop environment, you also have an identity disk that would be stored there as well. 16 megabytes, not big, but if you want to be accurate or exact, then you should be including it, and then obviously your differencing disk. But the thing I always see left out is the vSwap file, always. So with storage, with monitoring, right, at the end of the day, all I care about is latency. That's it when it comes to monitoring for performance. That's essentially at the end of the day, I don't care what the storage manufacturer does, whatever magic that they do or use. If they can provide my read and write requests within, let's say under 5 milliseconds, I'm happy. I don't care what you did with it. So just make sure you're monitoring for latency within your storage environment. That's the when I see VDI projects fail, most of them are because storage costs, or they have an existing environment and there's poor performance, and it's because of storage latency, things like that. Yeah.
Have you seen any customers set up a configuration where they put the vSwap files on a local disk?
Like on SSD and swap to SSD? I haven't, although it is an option. I didn't talk about it. My challenge with that is really, at the end of the day, there's a lot of brain damage around trying to figure out, like, well, I want to because all we're trying to do is like overcommit memory, right? Because that's when it's going to use, that's when it actually maybe use the vSwap file. I mean, the vSwap file is there for when we have memory contention, right? So you could also look at just turning on the reservation, getting rid of the vSwap file. Are you talking about swapping to disk, or are you just talking about taking it off of shared storage?
Well, both, right?
Okay. Well, one would be if for example, if you want to put the vSwap file on local disk, typically the design guide is to do it on top of SSD.
Responsive if you had it local disk versus out on the SAN?
I never want to use a vSwap file. I want to make sure there's enough memory in the system so that we never have to basically swap memory, out of actual RAM, to a vSwap file. That's what I want to happen. And with memory prices the way they are, I don't see any reason why that wouldn't be the case. So.
I guess the other configuration would be to put the page file on a local disk too.
Well, the page file, I mean, it's inside the VMDK, so you don't really have a lot of choice around where that one's going to go. I'd say, I guess if you're looking to get rid of the vSwap file or not account for it, put a memory reservation in for maybe 50% of it, right? Maybe not the full amount. Depends on how much memory you have on your VMs and whether you actually need to fail them over, or you're just going to leave them dead, right? I mean, if it's a non-persistent environment, why bring those virtual machines up somewhere else? Leave them dead. We're not going to fail the virtual machines over. There's another host that already has those virtual machines running somewhere else. So I don't have to worry about like if I need to land this somewhere and I'm reserving the memory, right? How many VMs can I really put on a host? So I would say just turn on the reservation up higher. Maybe have your disk requirements. What I also don't find is that people don't typically have, unless they're looking at all SSD solutions, they typically don't have a capacity problem. There's usually a lot of excess capacity in the environment. It's always IOPS that we seem to be short on. Now, with more storage manufacturers having these, all SSD solutions, it becomes challenging to find a way to put, now suddenly we are counting, every gigabyte. But I would recommend maybe just turning on the reservation and making the vSwap file smaller in that way. Because really, if you're going to do it on local disk, the recommendation is if it's going to be used, then you need that on fast disk. Otherwise, your VMs are just going to crawl to a stop. Yeah, I'm not sure that that model. I don't know anybody who's actually like constraining their box so much and planning on using a vSwap file and putting SSD in it. It seems like a lot of work to fix what you could just do with more memory. But that's me.
Interesting, thank you.
So my summary is really simple. Don't choose hardware first. Figure out what you're trying to do. Figure out how many virtual CPUs your VMs are going to require, how much memory, whether they're persistent or non-persistent, right? Figure out all of those things, and then look at your options as it relates to hardware, to servers and storage. Doing it the other way, just realize that, you might be choosing the more expensive road, right? In the case of the customer example I was using, I mean, the cost of doing blades is probably more than they spent on the blades at the end of the day, because that's how much more money they're spending on shared storage solution to back all of these virtual machines. And now they're also dealing with this huge failure domain, which is they know when the storage slows down, when they have issues with their shared storage, it impacts 2,000 machines at once, right? And so they're trying to plan around all these things, and I'm like, if you just on rack mount servers, some local drives, number one, you would have never had this disk contention, and number two, if something actually happened, the impact would be so much smaller. Because typically it's not all the virtual machines creating the I/O bottleneck, it's a subset of them. So statistically, it probably would not affect the entire environment at once. So I hope that was useful for you. Before you leave, if you'd fill out your session evaluations and tell me whether it was or was not, that would be useful for me.